Hello, ladies and gentlemen. We are going to talk today about the arcs of a circle. So lots of different new vocab you might have to use today, and this is vocab that we're going to continue using throughout the rest of the unit. So it is going to be important to understand what we mean, but we're going to do a lot of defining so it won't be too hard. So first of all, what is an arc? Well, an arc is a section of the edge of a circle. Let me see if I can get a different color pen here. All right. So, for example, if I take 2 points on the end of my circle, so maybe A and B are 2 points on my circle, and I connect them like that, that's an arc. Okay, so an arc is a section of the edge. A major arc is based on a central angle. So if I make this central angle right here, and maybe this is point A and point B, a major arc is an arc with the points of the arc. So think about any point on the arc outside of the central angle. So it's this big arc that's created. All right, so it's an arc with points outside the central angle. All right, so you can probably guess what a minor arc is then. If we take the same angle here, the same central angle, so maybe A to B, then a minor arc is going to be the arc where the points on the arc are within the central angle. So it's an arc with points inside the central angle. All right, excuse my messy handwriting. It's really bad today. Then we've got a few more things to define. Obviously, central angle. We've already defined central angle, but just so you remember, a central angle is an angle where the vertex of the angle is at the center. So vertex at center. If we draw two radii coming out of the center of a circle, we're going to make a central angle. A semicircle is an arc, okay? It's an arc whose endpoints are the endpoints of the diameter. So here's the diameter. This can create two semicircular arcs. Both of them are the same. There's not a major or a minor one since they're the same size. So a semicircle is an arc whose endpoints are the endpoints of a diameter. All right, and then finally, congruent arcs. So congruent arcs is just how do we say that two arcs are congruent? So there are a few different ways. We measure our arcs with degrees, and we'll come to that in a minute. But if we have two arcs that have the same measure, so maybe this arc right here and this arc right here, maybe both of those arcs have a measure of 50 degrees. If both of those arcs have a measure of 50 degrees and the circles that they come from are congruent, we're making our congruent radii to show that the circles that those arcs are part of are congruent, then they must be congruent arcs. So same measure, and they have to be part of the same or congruent circles. Part of the same or congruent circles. So we could have two arcs on the same circle that are congruent. So if this was another 50-degree arc, 50 degrees out of the 360 degrees surrounding the edge of the circle, then we could have two congruent arcs on the same circle. That's okay. So the thing that we want to know, or one of the things that's going to be really helpful to know, rather, is that if you're looking at the same or congruent circles, the chords, if the chords are congruent, for example, the chords on these arcs, this 50-degree arc would be this chord right there, and the chord right there that connects the endpoints of those arcs. If the chords are congruent, that means that the arcs are congruent. And if the arcs are congruent, that means the central angles are congruent, or vice versa. So for example, the central angles would be like the angles here and here that come out to create that arc. So if one of these three things is a pair of congruent chords, a pair of congruent arcs, or a pair of congruent central angles, then we know that the rest of the angles are congruent, or the rest of the chords, or the rest of the arcs. All right, couple of theorems about the angles, not the angles, but rather the measures of the arcs. The sum of all these central angles in a circle is 360 degrees. So around that central point, there are 360 degrees. The sum of all the arcs in the circle is also 360 degrees. So all the arcs together are going to add up to 360 degrees, and that's how we're going to be able to find the arcs that we need. So here we're going to name some arcs on this diagram. It says name first of all, a central angle. And remember that we have to name our angles with 3 letters. So central angle right here, here's A, and it's got 2 radii coming off of it, so we're going to name our central angle BAC. All right, so BAC, and of course we have to use the angle symbol, so it's angle BAC. To name a minor arc, remember a minor arc is an arc with points inside the central angle, so it's going to be inside here. To name this arc, we are going to use the endpoints of the minor arc, so that's going to be BC, and we're going to put the little arc symbol over the top. We learned that arc symbol on like the first day of class. All right? And then finally we have to name a major arc. But you might be thinking, well, if I use this arc, it's also called BC, so how can I tell that it's a major arc and not a minor arc? When you name a major arc, you want to name 3 letters, including one of the letters that the major arc passes through. So if you say BDC, if we call this arc BDC, with the arc symbol over all 3 letters, then we would know that this arc goes from B, it passes through D, and it goes to C. So it has to be all of these sections of the circle. And that's what tells us that's our major, or our larger arc, because it goes through all those 3 letters. So we want to talk about measuring some arcs here. So in circle P, the angle WPX is 28 degrees. Angle ZPY is 38 degrees, and ZW and VX are diameters. So they each cut off the circle at 180 and 180 degrees. Find each measure. So the measure of arc YZ is right here, and the measure of this arc will be the same as the measure of the central angle. So this is going to be 38 degrees. So 38 degrees. The measure of arc VZ is over here. So we have to think, well, how could we find this? And what I see is I see 2 diameters that make central vertical angles here. So this angle is going to be 28 degrees, just like its vertical angle, which means this arc is also going to be 28 degrees. All right, then we've got the measure of arc WX, and again, WX comes from this arc. The central angle is 28 degrees, so this arc is 28 degrees. We've got the measure of angle VPZ. So VPZ is here. We already marked it because we marked its arc. So VPZ is a 28 degree angle. The measure of angle XPY. So if we go XPY, this one needs some calculating. All right, but we do know that WZ is a diameter. So there are 180 degrees of angles over here. And if we do 180 minus 38 minus 28, we're going to get the measure of this angle right here. All right, so 180 minus 28 minus 38 is 114. So even though it doesn't look like it, angle XPY is a 114 degree angle. All right, then we've got arc WYZ. Well, WZ would be here, but WYZ is going to go this way. And actually, they're both diameters. So in this case, they're both 180 degrees because ZW is a diameter. So that's 180 degrees. The measure of arc XY is right here, and that's going to be the arc that is with this 114 degrees because that goes with that central angle. The measure of arc VXZ. So if we go from V to Z normally, that would be this arc and it would be 28. But since they said VXZ, we have to go around the other way. So starting at V, we have to catch X and then go to Z. So that's the rest of the circle except this 28 degree angle, or this 28-degree arc, which means that it's 360 minus this 28-degree arc, or 332 degrees. All right, and then we've got the measure of arc ZXY. So here's Z, got to go all the way to X before we go to Y. So that's all of 360 except for these 38 degrees. So it's going to be 360 minus 38, which is 322 degrees. And then the measure of angle VPW. So here is VPW. And since we've marked out the rest of our circle, right, there's 28, 38, 114, and 28, we could do 360 minus all of those. Or we could say, well, we know WZ is a diameter, so there's 180 degrees here. We could subtract this 28, and 180 minus 28 is going to be 152 degrees. All right, so lots of just piece by piece by piece, step by step by step work here. Here we want to talk about fractions of a circle. This is pretty simple. It says what fractional part of a circle is 120 degrees? All we need to do is we need to say that number of degrees out of 360 degrees, since the whole circle is 360 degrees. And that's going to be 1/3 when we simplify. So remember, we've got to simplify our fractions here, right? So 36 out of 360 is like 1/10. And then 200 out of 360, I'll leave to you. That's really easy. All right. Right here, we want to find the measure of an arc that is 7/12 of the circle. So if they tell you the arc is 7/12 of the circle, you know it's more than half, because you know that a half is 6/12. So the arc that's 7/12 of a circle is going to be 7/12 of 360 degrees. Remember how of can be multiplied? So 7/12 times 360 is, if you do 7 times 360 divided by 12, you'd get that answer as well, is 210 degrees. All right, so 7/12 of the circle is 210 degrees. All right, and then finally here we've got a arc algebra example where FC is the diameter and E is the midpoint of BC. So E is the midpoint of this arc, which means, let's make sure you can see that here, which means that EC and BE must be the same if EC is, well, if E is the midpoint here. So this should be 3x plus 16 as well. We want to find the measure of angle FAB. What we do know is we know FC is a diameter. So everything in this arc is going to add up to 180 degrees. So we can say 3x plus 4 plus 3x plus 16 plus 3x plus 16 equals 180. And then we can just solve this equation. So we've got 9x, we've got 16 plus 16 is 32 plus 4 is 36 equals 180. Then just solve your equation. Subtract 36. So 9x equals 144. Divide both sides by 9, and x is equal to 16. All right? But of course, that's not our answer. We want to take that and we want to make it the measure of angle FAB. So 3x plus 4. So 3 times 16 plus 4 is going to be 48 plus 4. So the measure of angle FAB is equal to 52 degrees. All right. On the back, we've got a triangle example. So last example for this section says if the measure of arc AB is equal to 102, and that would be like 102 degrees. So if we say the measure of an arc is a number, we mean it's that number of degrees. So if the measure of arc AB is 102 degrees in circle O, find the measure of angle A and the measure of angle B in triangle AOB. So we know that the arc cut by two lines going from the center to the edge is going to be the same as that central angle. So we can say that that central angle is also 102 degrees since its arc is 102 degrees. We can also say, oh, I see that OA and OB, those are both radii. So those are both the same length, which makes this triangle isosceles, right? Since this triangle is isosceles and it has two sides that are the same length, then it must also have two angles that are the same length. So we just need to figure out what those two are. Since they're the same, I can call each of them x, And I can say 102 plus 2x equals 180, since I know the sum of the angles in a triangle is 180. So then I'll subtract 102 from each side, and I get 2x equals 78. Divide by 2, and x equals 39. So find the measure of angle A and the measure of angle B. They're both 39 degrees, because adding them all together would give us 180 degrees. So the measure of angle A is 39 degrees, and the measure of angle B is 39 degrees. All right, hopefully that all made sense to you. Get at me with any questions if it didn't, and go ahead and work on your, what section is this, 10.3? On your 10.3 worksheet.